We're just pretending that it works. Okay, so the first model I'll do with this, and it starts respiratory lab, upper respiratory structures on model, like this. Then next week, we'll do this, to do digestion. We'll talk about the glands and the muscles. But today, it's the inside. Okay, so we're focusing more on respiratory. So respiratory would be nasal cavity, right? So here's our nasal cavity. So in our nasal cavity, we're going to have superior, middle, inferior concave, which is pretty much easy for you. And what innervates this superior concave? Olfactory nerve, innervating olfactory mucosa, because we'll learn in lecture tomorrow that the rest of this is all respiratory mucosa, which is different. It's designed as a filtering mucosa, not the sense of smell. So it's different.
Moistening and warming.
So here we go. So we're going to get our three regions of pharynx. So from the posterior nares down to the soft palate, that is considered the nasal pharynx. Oral pharynx goes from soft palate to approximately hyoid bone, so it's here. And from hyoid bone down is laryngeal pharynx. So you got the three pharynxes: nasal, oral, laryngeal, which makes sense. You think of laryngeal, this is this thing, is your larynx, okay? So in here we have hard palate, the red muscle is the soft palate, and right here is the uvula, the punching bag that hangs in the back of your mouth. Why do we have an uvula?
To throw up. And
Without an uvula, you wouldn't throw up.
Is it to block the
It's
entry?
right. It's when you're swallowing, it raises up and blocks off. It'll rise up to close off the nasal pharynx so the food doesn't go in your nose. It goes down where it's supposed to. A lot of times they'll go in and they trim this back. People with sleep apnea, they say the uvula's too big, it closes off the airway. So they'll trim it back with laser. And then you'll have the person complain that when they swallow a pill, instead of the pill go down, it goes up inside their nose. And then you're going to pour water through your nose to push it back out, and it goes down your throat.
That's why there's neti pots.
Huh?
Neti pots.
Yeah, you put a neti pot. Yeah. Right? And so again, the hyoid bone's here. So right here is the larynx, and this would be my epiglottis, just to give you a landmarks of what's on this thing. So it's kind of just like the picture in your book. So it matches it pretty good. Okay, we don't bother with the tonsils. We'll do that in lecture, not here. So that takes care of this model. Let's do this one next before we go to that one. So this will be on your back page. Larynx on sheep and model. The larynx of the sheep looks similar to this. Not as pretty. It's all one ugly brown color. Dead and gooey. So it's different. But here's your hyoid bone. What is the hyoid bone? It's known as a stabilizing bone. So why do we have it? Well, one, it stabilizes to open the jaw, stabilizes the tongue to be retracted back in, and it also stabilizes this region to pull the glottis, which is all this, up to the epiglottis, to close off this when you're swallowing. You can't breathe and swallow at the same time, or the water will go in your lungs instead of down the food tube, right? It goes in the wrong place. And if you don't believe me, we can try it with someone who wants to be a guinea pig. Take a bear out and let David show you how they can inhale beer.
Do it.
So, hyoid. So let's do the oids first. Hyoid bone, thyroid cartilage, cricoid cartilage, which is a total ring. So everyone that makes a total ring structure, and in the back are the arachnoid cartilages, which control your vocal cords. That's these in the back. So to see it on a real one, you'd have to split it, open it, and then you can see them because they'd be buried in the soft tissue, the arachnoid. So it's the oid family, right? Hyoid, thyroid, cricoid, arachnoid, O-I-D, they all end in oid. These are cartilage, this is bone. So the blue's cartilage, the white's bone. The epiglottis is like a tongue sticking up. Also in the back, which you should know what's not on here, is the trachealis muscle, because this is the trachea. And we're going to get into that on here now. So this would be the trachealis muscle. What sits right behind the trachea?
Esophagus?
Esophagus, then spine. Esophagus in the way, okay? So now let's get into this guy. So we're going to go into lower, back to the front page where it says lower respiratory structures on model, which is this, which would be this on you. So why, looking at it from the back, it's C-shaped hyaline cartilaginous rings. Why do we shape it that way, and why are they made of cartilage? Why is the trachea and all the airway made of cartilage?
Stabilize the structure so they don't collapse.
Exactly. Stabilize the structure so it doesn't collapse. Because every time you would exhale, this was all soft tissue, it would collapse, and guess what? You're not going to inhale again. You have to put a tube down there and blow you up with air like a balloon. So that's the reason why it's all cartilage. Why do we put a muscle back here? What?
Is it to help to move
To help move what?
the air, isn't it? No?
No.
Food.
Not to
Food.
So
Why?
because it contracts, so you would need like some kind of pushing.
Yeah, but the peristalsis is in the esophagus, so you're close with the food, now go into the esophagus, which is sitting right up against it. If this made a total ring structure, first of all, it would be pushing into the esophagus, so when you go to swallow something, it would get hung up other than water. So what this does, it gives the ability for the esophagus to expand into the back of your trachea for large food particles to go down into your stomach. And you'll see when you look in the cats, it's stuck right to it, attached to it. I mean, we do separate it, but it's attached to it. Okay, and that's the reason why. Also, if something goes in the airway, the muscle can contract to push it out, such as mucus, dust particle, whatever gets down in there. And when you cough, it creates so much force that it's over 100-mile-an-hour wind that comes out of your airway when you push with that much force. That's how much force there is. So you're like a hurricane when you cough and sneeze. Okay? A hurricane in your nose. So we look at this thing now, we can see all the major structures on it. So we're going to have, so here's your laryngeal area. We have a thyroid gland hanging right here. So the name things here, you can name here, right? Hyoid bone, thyroid cartilage, cricoid, hyoid, thyroid gland. In the back, the trachealis muscle we can see. All this is then trachea, right? Then we branch into our primary bronchi. There's one on each side. So there's the one that's A and B, the primary bronchi. Do they look symmetrical? No. Okay.
Because one has 2 branches and the other has 3.
But why else?
The heart is in the middle.
The heart. Well, he doesn't have a heart. He's heartless. He's his girlfriend. He's heartless. So the heart would be in the way. So we got to cross over it. So when you describe the left primary bronchi, you would say longer, narrow, more horizontal. The right, shorter, wider, more vertical. Kind of like the way you want to be described, how you build it. Long, short, wide, and vertical. Then, like you said, you have 2 secondary bronchi, because from this point here, you'd be inside the lung. So that means we're going to hit an area called hilus or hilar area of lung. And what we mean by that, the hilar region of an organ is the root of the organ. The organ would grow or bud off that as it grows. But it's also your main entrance point into an organ. So here we'd have primary bronchi, pulmonary artery, pulmonary vein going in and out of your lungs. Okay? And all this pipe work from here down is known as the conducting system of the lung. Not the respiratory system, the conducting system. It's just bringing the air in like these ducts are. Where things take place, it would be at the boiler or the air conditioner site where things are changing at that point. Cooling the air, heating the air, filtering the air. Well, that doesn't take place until you get into the alveolus of the lung, which you got to go through the bronchioles to get there. So that's where the actual respiration takes place of oxygen and carbon dioxide exchange. But this is nothing but conduction. So once we get in, you can either call them lobular branches because they're going to each lobe. So you'd have 2 on the left, 3 on the right, and because they're feeding each lobe. In the cat, you have 3 on the left, 4 on the right, because the cat has 1 extra lobe in each lung than we do. He's special. Okay? So the multicolored ones are the tertiary, or the segmental, that are dig down deep into the lobes now to break them up more. And right after this is where you finally go to bronchioles and get the alveolar, the alveolar branches for gas exchange. Okay, so all we can see is to the tertiary. We cannot see beyond that. What we have to work with, okay? So on here, it's pretty simple. The multicolored ones are the tertiary. The big ones branching off are the primary, and then the little ones that branch off of that are the secondary. So it's pretty easy. It's a very easy lab. Compared to what you've been through in the lab, this is one of your simplest labs. Okay? So that, and then again the back, the trachealis muscle, that kind of takes care of all your plastic stuff. David has a question.
Always. We're responsible for the cricothyroid membrane.
No.
I know how to perform the tracheectomy.
Yeah, so no, you're not responsible for that.
That's what's up.
But the cats have trachea, so you can see we popped holes in there so you know where your thyroid and your cricoid. We pop a hole between the thyroid and the cricoid. So
Is it the same on the cat as it is on
Yes.
the human between T3 and T4?
Roughly. Cat varies a bit,
I mean C3, C4.
so it varies. Okay, so there's a variation. Well, in the human, this starts at C6, and the bifurcation's at T4. So we'll learn, we'll get into that in lecture stuff, not here. So the rest is the sheep plucks. Now the pluck in the big bucket, in the little bucket's the larynx, the big bucket's plucks. This forward. The pluck contains all of this with the heart and lungs hooked to it still. So you can actually see what it really looks like in something that's big compared to what's in the cat. When you go in the cats, the left lungs have been cut, so you can pick them up and look at them. When you look at a left lung, it's always going to run, when you look at the hilar region of the left lung, it's always going to run, so if this is the lung area like this, and this would be the hilus region, well the artery would be here, the bronchi, so this would be artery, bronchi, and vein. That's how it runs on the left. So we just bother with the left because there's too much variation on the right. But you learn it on the left, and the same thing when we look inside there. So you'll see that. Notice what it's telling you for this time. Usually arteries are red and the veins are blue. But in this case, the artery is blue and the vein is red. Why?
Oxygenated and deoxygenated blood.
Because the artery is taking deoxygenated blood into the lungs, and then the vein bring it back up
Right, we
into
didn't
the
explain
heart.
it. So. You have to explain, David. Explain.
Yeah.
Explain, David.
I didn't teach you statement.
Explain, David, explain. Okay, so she's right. What's happening from your right ventricle, that blood's just returned from your body, so it's going to get pushed into the lungs now to get oxygenated. The only thing that leaves the heart are arteries, and veins always enter. We'll learn that when we do the heart in 2 weeks. So the veins returning from the lungs to the heart would be very rich in oxygen. So you can't make a statement in a true or false question that all arteries are rich in oxygen. The statement is false. But if we say all systemic arteries are rich in oxygen, then it becomes true. So you got to pay attention to the wording there. That separates the 90 from the 100. So yeah, you're so fantastic. He loves true and false. He's going to become the true and false master. I will master taking that. I will master beating it. Now, when you look inside the cat, there's 3 nerves you're going to look for, and there's 2 arteries. You're going to look for the common carotids, left and right. Running with the common carotids will be your vagus nerve, left and right vagus. So they'll be running up here. Little vagus goes down here. The pharynx will be on each side of the heart, running towards the diaphragm. So you get the left and right phrenic. And the sympathetic nerve or ganglia, which is more like a nerve in the cat, well, where do you think it would be? It would be down paraspinally, right on the rib cage. That's where it'll be. And you'll see it right, usually medial to the cup where we break the ribs, so you can see it from the back. So it would be very close to the spine running here. Okay, that's where it should be. All right? So those are the 3 major nerves you look for in the cat today, in the 2 arteries. Also in the cat, when you pick up its lung, it's a decent lung, you can see the blue, the red, and the primary bronchi, and you can see it against the cap where you've cut away from the heart. So you can actually see the primary bronchi with the pulmonary artery and the pulmonary vein. It's all there. So you can see this stuff. And the pluck, it's easier because it's bigger. And the pluck, it's not color-coded, so you go by thickness of wall. If it feels nice and thick, like a nice fettuccine noodle, then I got an artery in my hand. If it's very thin and feels like tissuey, it's more of a vein. And then, of course, if it's a rigid structure, it's the bronchi. So it's very easy to see. You can see the diaphragm nice, the central tendon, the muscles on it. The muscle looks like corned beef. That's why you're looking at the muscle. So you'll be hungry after lab. So you want to have corned beef and cabbage. And it was on St. Patrick's. Time for a Reuben. Time for a Reuben. Okay, so that's pretty much it. The lab itself is not a killer lab today. It's very easy to get it in your head. You know, lecture-wise, a lot more detail we go into than here. Same thing, GI tract next week. So your labs from this point on really are not as intense as they've been. They're mainly just one sheet of material. Okay, so to me, your worst lab was your first set, tissues and bones. And the muscles are kind of with the nerves. But when you get into the organ systems, that's why we can throw 5 systems at you, because they're kind of like, you kind of understand the names already. You know trachea, you know bronchi, you've heard these terms, they're not new to you and strange like some of the other stuff has been. So it's not too bad, okay? So dig in and have fun. Of course the cats are put away wrong, they're inside the trays and everything. Why is it crappy to put them in that way? When you take them out, all the chemical now is on the bottom of the tray and gets all over the table. Where if you just put the cat inside the bag, that doesn't happen. So this is why when you're done today, you're gonna, and it looks like we're missing, yeah, in the bag. The bag is over here and the cat's over there. So that does a lot of good to keep it moist. Oh, please. I don't know why you bought
Where's the
that.
fish bone?
Alright, so once you get going, I'm gonna pass the practicals now.
I got she's okay.
So this is looking at a real McCoy, okay? So this is an actual larynx. See, it's not as pretty as that big blue one. So here would be my hyoid bone. It's covered with the, you know, there's a lot of different hyoid muscles that come off it. This would be the thyroid cartilage. And right here with muscle ridge on it, right here, would be the cricoid cartilage, okay, going all the way around. When we open them up and get inside him, here's the arytenoid cartilage. See this? That's the arytenoid, which is controlling the vocal folds. So that's what it's there for, to control the vocal cords. As they move, they tighten or loosen the cords, so when you talk, your sound changes. Here's your epiglottis, looks like a tongue. On this one, it actually has the esophagus on the back. So you can see, as this would pull up and shut down, it would open up the esophagus, so you can get down inside the esophagus. And right here, this would be the actual thyroid gland right here. And that's all the structures on this guy. So now we go to our pluck. So this would be it's got a nice long trachea though. See, if it was on us, you'd think it would be down here somewhere. So it doesn't work out too good.
Stop moving everything.
So first thing, let's look at our diaphragm. Here's the diaphragm. So we open the diaphragm up. Here's the central tendon of the diaphragm. And here's the muscle, which is all skeletal muscle. Innervated by phrenic nerve, which probably isn't on here. Because sometimes you can file it down and see the phrenic
Right there,
nerve.
no? No, that's not it. That's a ligament.
It's just, no, that's not a ligament. That's the inferior vena cava. That's what's holding this on. But in this case here, it's a skeletal muscle that has autonomic innervation, even though it's a spinal nerve. And it's C3, 4, 5 will be the roots of it. And how are you going to remember that forever? C3, 4, 5. Keep your diaphragm alive. 5 alive. Keep that in your head, okay? So you have that. So next time when we do the heart, we'll go through all these other vascular structures. But right here, you can see the pulmonary trunk leading to become the pulmonary artery. The primary bronchi is right here, And underneath it is the pulmonary vein, because that's the way we run on the left side. It's much easier to see it on the left than the right. So again, the artery, the bronchi, the vein. So this would be your hilar region right here. All right, because here's, you know, your trachea coming down.
Hilar, right?
Hilar or hilus. Okay, so from the back, it's much easier to see the bronchi branching, your primary bronchi. And as you get deep into these lungs, you can actually see it breaking into the secondary. See? You can actually see the secondary right here branching. The other one should be going anterior. That's the vein. If we really get deep, is the other secondary. See it? So you can actually see the secondaries forming when you get deep inside the lung. So your primary is your main loop going in. Then as soon as it gets inside, it branches to your secondary and eventually down to your, so if you were to open this all up, you'd see that. If you go on to look at the cadaver dissection that's in Blackboard, on the web link, no, the cadaver dissection of the cadavers on Blackboard. There's a web link. You go to cadaver dissection. It has a whole great dissection of the human lung and the human heart out of the thoracic cavities. And she does a great job explaining this, showing you the same structures I just showed you, but she does a great job with the heart to learn the internal and external heart, because she slices the heart open and look inside. So it's really a good video to take your time looking. And in the back here, you can see the trachealis muscle. So you can feel how soft it becomes. And at this point here, you could get through it because there's the trachealis muscle. So this will actually push itself in so you can get through. Okay, so it's probably cut just before where the larynx would meet it, is where it's cut. And that's it. There ain't no more. Okay? Now we'd have to do cat. Take a break for 1 second. So, yes, this won't happen again. I think it was the sis that made her mean, because she's nice to me. That's what it was. I never knew that. Okay, so we look at the cat. So here's his diaphragm, beautiful diaphragm, okay? This one, his phrenic is still intact. See, as I pull on it, you can see his left phrenic perfectly in place, okay? If we go over to the right side, here's his right phrenic in place. So you're gonna notice the phrenics will have a tendency to run anterior to the hilar region, because here's my hilar region. So here's your pulmonary artery, primary bronchi, and the vein. Oh, that's still bronchi. This would be primary, this secondary. The vein would be down here. You just can't see it well, but it's right there. So that's where the vein would be. So it'd be artery, bronchi, vein, just like it, where'd the lung go? Here it is. Just like it would be on the lung. Here's the artery, here's the bronchi, and there's the vein. So you can see it, okay? So you already branched it into a secondary here. So the primary would be a little over here more, okay? But this already branching off into their secondary. But there's the artery, because the artery's blue. This should be a pinkish red color. It's browny, ugly color. There you go. So as we come up, so our diaphragm, so we come up here now, and we can see we have here's our trachea. Right behind the trachea is the esophagus, okay, and this trachea is open. We pop this open on purpose so you can see your thyroid cut from your cricoid. If we go here, here's the thyroid gland right there. As we come down now, here's your left vagus, left common carotid, right common carotid, and the right vagus right here. See? So there's your carotids. And then here's your vagus on the right, vagus on the left. The vagus, carotid, common carotid, vagus, and internal jugular run together. And what they call the carotid sheath. And the same way in the human, that sheath would be totally wrapped. So you'd have to open that sheath to get to these three structures. And you do when you go inside the human to get there. I think that's it for today. We don't need anything else on the cat. What I can think of. Can I see the sheet quick before she's done filming here? This it right here?
So we don't have to know the lobes and stuff?
No, you want to? I can make
Oh, no.
No, there's enough to learn.
Oh, no.
Go no.
Why you get digested? Where's the rest of it?
I just don't want to walk into the, you know.
I know, he blinds
No, that's it.
That's it?
That's it. That's it.
Oh,
Told you, it's
that
an easy
bag
lab.
chips. All right. That's a cut.
That's a cup.
That's a cut.